Hello everyone. In this video, we'll learn to develop neural network toolbox in a MATLAB environment. The basics of neural networks is explained in the previous video and the link is shared in the description box. So a neural network is trained to perform a specific function by adjusting the weights, and these are all the weights. These weights are adjusted such that a particular input will give us a specific target output. So in this video, we'll get an insight of training a neural network to fit a function using a neural network toolbox. So to do so, first we'll go into the MATLAB. So in MATLAB, in the command window, let's type the function nn-tool. So and this MATLAB belongs to 2012 version. So you have a command window prompt. So in this command window prompt, let us type the syntax nn tool, neural network tool. So click enter. You will get a neural network or data manager toolbox. So this toolbox consists of input data, target data, and any delay states, and this is the network. In this we can build any type of network and will get the output data. So if any error arrives, it will be showcased in this error data. So these are all the layer delay states. So you can input any data file and you can also create a new layer by using this new command, and this is the close and help option. So now we'll generate a new layer. So let's go and click the tab new. So in this we'll go for the data, and here we are going to create a perceptron network. So the aim of this video is to develop or create a perceptron network to perform the AND logical operation for any two variables. So in this we'll type the input variable P, and the data type is input, and here we'll give the truth table xy, and that is 0 0 0 1 1 0 and 1 1. So we'll have a square bracket 0 space 0 space 1 space 1 with the semicolon, 0 space 1 space 0 space 1, close the bracket, and just click the create tab. So new inputs will be added to our network or data manager, and this is the network data manager box. So click it OK, and you can see our input data in the name of P variable is generated. Now we'll go and fix our target. So click the data type target. So here our data type is T. So for the AND logical operation, our outputs will be 0 space 0 space 0 1. Only if we have the input 1 1 will get the output 1. This is for the AND gate. So now just create OK. So you can view a target variable T has been created. So now look in. So input data we have fixed as P and target is T. Now again move for new. Now we are going to build the network. So since we are going to perform AND operation, we'll name the network as AND net. So this is our network name AND net, and this belongs to the perceptron type. So let's make the network type as perceptron. So input data. So in input data we have fixed the variable P. So let's select P. Same way target, the variable name here is T. So let's click target T. So the transfer function we are using here is the hard lim function. So hard lim. So it is also a limit transfer function. So the main objective of using this transfer function is this will force a neuron to give output 1 only if the network is reaching some threshold value. If not, else the output will become to 0. So this is mainly used to train the perceptron network. So the learning function here used is called as learn P. So this is the perceptron weight and bias learning function. So let's create, give OK. So let's see, and network is created. So now let's go and start training this one. So what you do is we need to double click at the network. So this is the network we have created. So see, So this is the neural network. We have input, hidden, output layers, and these are all the weights. The same way here we have created, this is the input layer, this is the hidden layer, and this is the output layer. So this is the weight function, bias function, and this is the activation function. So input multiplied with the weight and then activation function will get the output. So this is a single layer. So this is our AND network, and now we are going to train our networks. So input, so we have fixed the value p, targets it is t, and outputs will be saved in the name and net outputs, and the error if we obtain this will be saved in this name. So now let's train the network. So if we train, so this is our network and this is the algorithm we are used. So the algorithm, training algorithm is cyclical weight or bias rule, and what performance measurement we are making is it is based on mean absolute error. So what does the progress describe here? So we are getting our exact output, that is error has become 0 at 5 iterations. So which means that during 5 iterations we are getting minimum error, that is 0 error is obtained in the 5 iterations. So the performances we are getting 75% of performance, and this is also plotted. So this is our plot, performance plot. So at 0 epoch we are getting 0.75, and this is done in the 5 epochs. So minimum error is obtained in the 5th epoch, and the value, performance value we are getting is 0.75. So this is our performance plot, and this is our training tool, and this is our network. So here we also have simulate options to simulate our network, and we can also reinitialize our weights. If we need to view or edit our weights, we can edit the bias, we can edit our weights using this tab. So you can click the train network and you can see. So once the network is trained, again if we train, the value will be 0 only, so you will not get any value. So let's see, the output data are stored in the tab output data, and error data, since we don't have any errors, the value will be 0 here. See, the values are 0. So in the output we get the 0001. This is our output value obtained, and this is our network. So this is our network, this is the output values we have obtained. So we have developed a perceptron network, and we have also performed the AND operation using two input variables. So this is the development of neural network based applications. Thank you.